Well, happy belated birthday.
I was here in class for my birthday.
Oh, I didn't know that. Happy birthday.
You get old, it's not even to celebrate.
Snacks for your birthday, all right? There you go.
What was that?
You got free snacks for your birthday.
Yeah, I did. I got some free things,
What do you do for your birthday?
Okay.
Oh, he
I
went
take-
to work in school.
I took CIS47.
Hey, he has forensic lab.
I was chilling here for time. What did we do? We did the package tracing. Oh no, we did the Cisco.
Okay, so we're gonna do a little bit of the DNS lecture today, and then next week we'll work on DNS servers. I thought about doing DNS servers today, but I want to wrap up some routing and switching command line as we've been using Packet Tracer. Let me get caption, otherwise I don't have. Okay, so we're gonna cover unit 9. If we have a little bit of time, I'll come back to a little bit of subnet exercise from the workbook that I have given you guys for extra credit. If you attended the cybersecurity events last week, you can submit that for extra credit as well. So in this week, we're gonna talk about network services and a little bit of configuration on the server side. We're gonna focus on DNS, NAT, and DHCP, and we will install these rules and configure them for the future lab starting next week. And then I am working on giving you guys access to test out, so that way you can have access to the practice test and additional labs if you need to. In this class, I customize, I write all my labs, so it applies the concept, but you can also have access to test out when you have a simulated lab environment. So look out for the email. I don't know, I think I should activate it online, but sometimes that creates problem for students. Okay, so we'll start with DNS, domain name system or domain name server. This is important. Everybody uses this because if you have a .com, .net, some type of website, it is tied to a DNS. And then for the regular network, you use this for the people to have access to your network. Like your systems need to join to the domain so that way you can control by applying the policy. So this is what it would look like. When you're looking at the domain, the dot is going to be your root. So that's top level. Then you have the .com. So if I have Microsoft.com, or if I have an extension of that, a child server, right? I would have it under the hierarchy for this particular domain. So your LAN can be expanded in a hierarchical structure, and you can have internal or external services. So let's answer some questions. So for number 1, it asks you, how can you set up an internal and external DNS zone? When you install your DNS and configure your DNS, what you will do is you will have to set up a zone. And these zones are tied to your DNS records. Or you can have different domain names for each of the zones, like the picture was showing on the first page of your notes. You can have Microsoft.com. You can also have a different domain name, right, from Microsoft.com as a separate domain zone. So zone records can be created and managed in the DNS environment, so that way you can either include or separate or structure your network or your domain. And that's important to think about when you're designing a network or expanding your network. So in the case where you see company buying out another company all the time, right? When you're merging the systems, it takes time because you have to be able to make sure that we have the proper systems to be able to bring in the data, and then we have to have the bandwidth to be able to support additional extension of our business. So acquisition is a little bit different when you're looking at companies buying out another company, or company of expanding to other locations nationally and internationally, you know. So a lot of that comes back to the engineering of the network and how we will be able to accommodate with services and bandwidth. So what are these zones gonna look like? You're gonna set up two types of zones. One, you're gonna have a forward lookup zone. And this is going to be using the frequently domain use, domain name, like the .com, the .net, the .gov, right? And if you're saying Microsoft.com, that ties to an address, or Google.com, that ties to 8.8.8.8, right? So it's associated the name to an IP address. It's kind of like how when you register for school, your name is tied to your student ID. And it's exactly that, right? Name to an ID. So when we're looking at the system, this is going to be either internal IP, if you're looking at the internal network, or if you're looking at like a web server with a domain name, then that would be your public IP. So we would need to set up a domain name that's tied to an IP. And this is just the first step, right? So when you configure it, when you elevate the role for that system, you can have a server install the DNS role. And then when you configure, you basically say that this .gov or .com or, mycompany.com, right, is tied to this IP address, and that's going to create a forward lookup zone. Now, the reverse lookup zone is often not normally always set up, right? But you can set it up where it will associate IP address to a name. We don't go around and say, hey, visit my company website. It's 14.5.11.172, right? We don't go around speaking IP numbers, or imagine if you have to give IPv6 number to people, right? So as human, we are more frequently using the domain name as URL that would tie to a web server. So it's normal that you would have this first, and sometimes you don't need the IP to the domain name, but you can, right? You can set that up. So if I type in who is, right, an IP address, and it's gonna say this IP address belongs to google.com, microsoft.com, etc., right? Mycompany.com. So it would be a way to look up, reverse, right? Look up your IP address to a domain. So that's important to think about when you set that up, and we'll do that next week before Thanksgiving. Okay. So when you look up the information from your notes, right, it talks about that here. And here it talks about internal and external, how you can separate the internal zone from a DNS zone. And from a security standpoint, that's important. We need to logically think about how things are included or separated, right? Because a lot of the times the recon part of the attack is they're gonna try to find as much information as they can to be able to find a flaw in your particular network. So when you set that up, you need to think about how your information can be internally included or externally excluded, right? On how it's separating the zone. And then if you're hosting with cloud, that's considered a third-party hosted system where you would rent your servers from Amazon or GoDaddy or Microsoft, right? Or Google, and then you would be able to set it up. So you would have an external DNS, and that's okay because I think it's cut costs, and a lot of people are doing that these days. Okay, so we talked about that. And then the next part, it talks about primary and secondary DNS zone. So the primary DNS zone contains writable copy of the DNS database, right? That's important. It has writable copy. So it's going to be able to save the information. With the secondary DNS zone, it's a read-only database. So when it receives the information from the primary, it just holds that information, right? It doesn't update compared to the primary where it can change. So for 3, it says describe the roles of the primary and the secondary DNS zone. You can find that on the notes. It says the primary DNS zone contains writable copy of the DNS database. And you might have top tier, right? Top of the forest, you might have Microsoft.com, and then you might have a secondary DNS, right? You might have another domain like live.microsoft.com, and then you might have outlook.microsoft.com. You might have, but ultimately, if we separate that, it becomes outlook.com and live.com compared to what you would see as part of the hierarchy that's structured back to the root. So what you have is the primary DNS zone. When we create this, it is a writable copy. So in a DNS poison attack, what you see is they would try to get your DNS records on your DNS server and be able to modify the records, right? Because we have the domain is associated with the IP. If I want to redirect everybody on that domain, simple. If I poison that record, if I modify that record, right? And then I would update the zone so that way it becomes now part of another server, right? Externally. So what you see is that there's some flaws in DNS, and so this is why we always use DNSSEC. And then the secondary zone, we talked about how the DNS zone for the secondary is a copy, which is a read only of the primary. So when we're looking at DNS records, right, we got the A records, which is created when you set up your DNS. And when you go through the prompt and it asks you to put in your domain information, right, and it's associated with the static IP address that you have on your server. So when you promote that system, when you configure that system, we call that a domain promotion. You bring that system to a role of a DNS server, right? It's going to provide services to the other system as a domain name system. It's going to translate how the other client is going to be connecting. So when I'm joining the system to my domain, I simply go into my system, the system configuration, and then I find the domain. If it's part of the network and it's allowed to do that, you'll be able to join. So all of that can be configured in the system property. Now, for the DNS record, the question number 4 is tells you identify the DNS records that's based on the functionality. A, specify which DNS server is authorized in the domain and where to find the domain's IP address. So when you do a promotion, that role is then going to be identified in the NS record. NS record is going to store the DNS server that is authoritative to the domain. Now, you don't have to set up authoritative right away, right? But ideally, you should have this set up throughout or before you deploy. When you go through the lab, you will see that it will tell you that, oh, you might not have a DNS that's authoritative right now. Do you wish to do that? And you can set that up. Another record that you need to know is the CNAME. And this is where it has the name that points to another host record. So this is how we can identify the system by the name, right? So that would be a record. So these are just files. So think of them as reference files that the system contains, so that way it would quickly associate things like IP address to name, which is the DNS, which has this name and what that name is, what part of that domain, right? Of which domain. And then your PTR, this is for reverse lookup zone. So when you create a reverse lookup zone, this record is going to update and it's going to associate the IP address to the DNS name. Think of it like a contact list, right? You have someone's name and then their phone number or their email address, right? The PTR is the other way. You would have the IP address, which is like their phone number that's associated to the name. So it's just a correlation in the list that is different, one is going to be name to IP, the other one is gonna be IP to name. Any question? And then your SOA, this is going to store your zone settings, such as increment numbers or version number, or any time that you have zone changes. So when you update your zone, SOA is going to have that stored, so that way it would be a reference point, right, for the other records. Now, ultimately, like I said, DNS poison is about modifying these records, so you have to make sure that you protect these records. Okay, so there is more, right? I didn't mention the host A. This is going to resolve your URL or frequently used domain name to an IP address, right? This is how we type things into URL or domain name anyways. And then your quadruple A, which is the host, this is going to be for IP version 6. So if you're using IP version 6, this is going to be your host record. Alias is known as the CNAME. We talked about that one. And if you have an email server that's associated, the role is associated with your domain, like RCCD, you know how you have student, right, at rccd.edu, and then they have the RCCD. So that is just a child of, right, the RCCD domain. So your mail exchange is going to be your MX record, and this is specifically for mail for Microsoft. And then your name server, we talked about NS and SOA, startup authority, your pointer, and then your SRV, this is for service. So if you have specific service, this is the file that stored that service information. Now, dynamic DNS, this allows you to have non-secure updates, or you can set up secure updates. You have to configure access control in this point. So you can use DNS Management Console and be able to right-click the zone and then choose the property, and we will go through and take a look at the dynamic updates. Okay. Now you want secure updates for your DNS, so you should use DNSSEC to set that up inside. And when you're going through the wizard, it would ask you anyway. Okay. So for number 5, it says, what type of protocols allow the system to contact DNS server and update their own records? And that will be the dynamic DNS. And so that allows the system to, now whenever that you're trying to contact the domain and it's not there, right? So ultimately our system is, we can use things like NS lookup, but when it's trying to reach a domain, it's basically looking for the IP address or that name, right? And if there's a file that references that name, then it's going to be associating that to that particular domain through authentication process. So when you're logging on to RCCD, right, when you're using the RCCD system like these right here, these have been joined to the district domain, the RCCD domain. So when they set up these computers, right, they already on the image or on the operating system configuration, they already joined the system as part of the domain. So that way my credential will work with that particular domain, right? I don't have to go to a web service or a VPN to be able to authenticate remotely. So I can utilize that system. I just need to authenticate to that system. Now, when you're using those systems, how it's contacting and it's going to update the records of the own system through the dynamic DNS. Any question regarding DNS? Make sure for Network Plus, we know what it does, right? Some detailed information about DNS. Now, frequently you would see that you would have a server that holds many roles, DHCP, DNS, right? Active Directory. Whenever that you have DNS, you would also have AD, which is Active Directory, and that is allowing us to manage objects, right? And also subjects within the actual domain. So Active Directory allows us to manage groups, users, computers, and also any kind of replication with the subdomains or any other objects within the network. Now, for the DHCP, this is mostly to handle IP address assignment, right? So DHCP, Dynamic Host Control Protocol, this allows you to provide or automatically configure IP address for the systems that are part of your network. So if my laptop, right, is at the campus and I connected it, I joined it to the domain, right? You see this when you're using the wireless network, you're obtaining an IP address from its server, right? That's the whole point, is to control and provide services for your client system. So when we created a scope for your DHCP, what we're doing is, I think you did this already, right? When we did the IP addressing, we talked about that. You're making a pool that you can give out the IP addresses in that pool. So the process entails 4 steps. First, it's gonna see who's there, right? It's gonna look for which server is gonna give it an IP address. It's gonna say, who's the server? Then the server is gonna say, I am the server. I can give you an IP. And it's the client system is gonna say, I want an IP. And the server is gonna say, here's an IP. And that's the 4-step process. Discover, offer, request, and acknowledgement. And you see this when you're scanning Wireshark, right? If you're looking at like specific DHCP traffic, you would see them. And you would know who's requesting IP addresses. And so when you turn on the computer or when you join a wireless network or when you join that domain, there's 4-step process for that system to obtain an IP. Now we can do the same thing with remote access. So when I connect via, virtual private network, right, I would authenticate, and at the point where it acknowledged my authentication, it's gonna say, okay, right, can I get an IP address from a server? And the server says, I'm here, I'll give you an IP address, and the process continue, right? And then you become part of the network, even though you're remotely working. So, and then it also talks about the length of time for the client for the IP address assignment from the DHCP server. Now, when you did this, you went through a DHCP reservation, right? This can be set on the scope. And when you set this up, you can reserve some of the addresses where you did exclusion, right? So let's say that I have a scope 1 to 100, right? I created this large scope, but then I realized that, oh, I have printer, I have copier, I have a couple more servers that I gotta throw on there. So I want to exclude some of those addresses so that way it doesn't give it out, right? It's kind of like you would keep it aside for another use, and so you don't assign it. So that's an exclusion. So you can also set up where you would reserve certain IP addresses that's always going to be the same IP addresses for those computers. So this is kind of like the VIP IP addresses, right? It's always going to be that set of IP addresses that it's going to assign to, let's say, your game console or whatever, because you are setting up port forwarding for your game and so on. So there are ways that we can control how our scope is going to be when it's distributing IP addresses. We don't want to just throw out everything, right? That's too simple. We want to be able to manage it for the efficiency of the network. So for number 6, it says, what is a DHCP scope? Basically, it's a range of IP addresses that the DHCP server can lease to the clients. This is the IP addresses that it's going to give out to the computers that are on the network for a length of time, right? There's an expiration date that we can set up, and you saw this when you did the DHCP pool. where you would say, I want this to expire every 90 days, or 30 days, or 27 days, or even shorter, right? So by default, we can have it by default, but you can have it longer or shorter to your needs. So that's basically an IP address. And then when we're using IP version 4, this is when your subnet knowledge comes in handy, right? I need to know, I can create various scope for various purposes. I can have, for example, the scope for the wireless side, right? That might use 192.168.0.x. And then I might have the wired side where it uses class A address, like the 10.0.x. Or I can have, so you can have variation of IP addresses scopes, and how you interconnect is you can route things in or control it through VLANs, which we talked about today for the lab. So that's important to think about. And then for number 7, it says, what type of address is used for DHCP discover message? So when it's saying, who's the server out there, right? You look at it, that's a broadcast address. So whenever that you see hexadecimal values that are all S, right? It's gonna say who's there, right? It's kind of like you are on the loudspeaker and you're talking to the world, you're gonna say, who can serve me? So that's usually a broadcast address. And this is gonna send to all system to identify who are the DHCP server. We don't just have one, we would have many, right? Because if you have one, it becomes single point failure. If you have many, right, for a larger enterprise, for thousands of systems, that would accommodate the needs for those. Now, let me bring 7 down. Now, after it offers the IP address and the client receives the IP address, it's going to acknowledge, right? You have an ACK message where it indicates that this is the IP address and this is the amount of lease time for this IP address. And it also includes information like router address and DNS server address. So when someone scanned, like using network sniffer such as Wireshark, you often see that this information is disclosed, right? You would see some form of messages. So in the final acknowledgement, it basically summarizes the lease information of the IP address. Who gives it, right? How it's gonna route the traffic, how it gets there, and also the domain structure or the DNS information, because that's the domain that you belong to. So the server sends that final acknowledgement to the client system. Any questions? Now we also have forwarders, the system that would forward, right, the traffic to DHCP server. You can do that. You can create it for management reasons. You can also use it as just for regulation purposes, like to regulate the traffic or monitor the traffic. You can do that when you don't want your server to be too busy, because remember, it's 4-way communication for each system that's trying to join, right? So let's say that you have 6 servers, but you want to have some middle servers that's gonna forward that information. It's gonna check and say, okay, well, I'll forward it to the server now to be able to offer the IP address. So that way it can handle, it's kind of like, you know how when you're trying to visit someone's office and then you have to stop at the front desk to sign in and that person will tell you, oh, you can go to that office, you can go to this office. So the forwarder acts like that. It's gonna say, it's gonna point to which server that will be responding to the request of the client. And it's a way that we can control how the request is. And, you know, for now, I think that in my ethical hacking class last semester, I talked about how now we create a black hole where we can, when we see a certain irregular traffic, we'll dump it there and we will kind of monitor it and see before we would respond to it, because when they flood the network is when our system gets too busy. And it makes our system become unavailable. So what you can do is you can set up relays and also like IP helpers to be able to regulate some of that. There are ways that we can also set up, like we can set up filter and proxy and firewall and other things, but a lot of times we want to make sure that we are more proactive than reactive in how we're controlling the network. So the relays, the DHCP relay is just a forwarder that takes the discover message, because remember, if broadcast is gonna say, who's the server, it takes that and it's gonna forward it, it's gonna relay it to the actual DHCP server to be able to get some response, right? You can have it from, so especially when you have clients from externally from different networks. And external, we want to be able to control that. So that's kind of like our little gatekeeper on how we would be able to provide service. Any question? And so on page 4, you can find the relay and IP helper information. This is the screenshot for how you can set it up. You can do it on a router like this. This is a router configuration for Cisco. Right? You can do IP helper address. Now, depending on the system, so you got to make sure that you review the specification of the system information. Otherwise, right, if it's not able to have this feature, then you won't be able to set that up. And then you can disable messages by using no IP. Anytime that you use no, usually that disable or remove. So if you have IP forwarded, right, enable, if you type in no IP forward, that allows you to disable it. So it doesn't have to be like a Windows server. You can have it as a network appliance. Normally you see relays as network appliances. Sometimes you would see security appliance act as the DHCP forwarder and also server. So you can do that like, we previously used ASA, you know, if you watch my older videos, I had my class configure ASA. ASA kind of went out a while ago. They replaced it with other security appliance. We'll use a different form of security appliance. And you can find ASA appliances from Cisco because if they discontinue it for very cheap. You can configure it with graphical user interface or command line, and that's useful. You can also use packet tracer. I think ASA is on there. You just need to download the image for the packet tracer. Okay. All right, let's talk about network address translation. I know many of you use VirtualBox and you've seen this. I have you configure your network settings on VirtualBox. By default, we keep it as NAT. You use NAT all the time, right? NAT. This is a very common service for home, for business use, for every single network. This is allowing you to translate your private IP address. Like at home, you use 192.168.0. Let's say 11. And that gets converted to your public IP address. It's kind of like how this is a system where it takes your nickname and translate it to your legal name, right? What the world sees you and what people sees you at home. So network address translation allows you to use all your home devices with one public IP address, which is what you have from your internet service provider like Frontier or Verizon or AT&T or Spectrum, right? So it allows you to share your IP address for all your private systems, and then you can also hide internal private address. So it doesn't disclose your private address to the outside world, right? Everybody sees you as a public IP address. And so this is important, right? I was talking to a student earlier before you guys came, and I talked about how, like now a lot of the streaming services, this is how they bill you, right? Like, for example, if you have Netflix, before you can share accounts with your friends, your family members, they didn't care, right? At the beginning. And now they changed so if they see that you using your account at 5 IP addresses, let's say, even like, let's say that you share it with your friends because they have your password, they're able to log on to Netflix, then now they charge you a family account, right? Where you have to pay a few dollars more a month. So how do they know that? Well, it sees the device coming, submit the streaming request. Let's say I click a show or a movie. It sees that from a certain public IP. And so if 4 people are watching from 4 different IP addresses, guess what? That's 4 different locations, right? So that's how they're able to see that, oh, now we're going to bill you a family account versus an individual account, which is cheaper, right? So, but ultimately, NAT provides you a way to convert your private address to the public address. So question 10 asks you, what type of NAT uses multiple public IP addresses and map it to one private to one public address? And that's called a static NAT. So when we have a one private address to a one public address, like your smartphone, right? Your smartphone does that. When you sign up for Verizon T-Mobile, you sign up for one public IP, and you internally, you're gonna have map one private IP for that, right? So in their internal network, you only have that one static net. So a way that we can set it up for this is for specific use where we would only dedicate maybe for network appliances or, systems that would be for communication, we can use static net. Now, when you have one public address for all your devices, which is what you have at home, right? That's called overloading net, where I might have 20 devices that I would use and I only have one public IP. Do you ever look up your public IP information? Right, you can go to your service provider, you can use Whois. I think we talked about that before. You search for Whois on Google, right? And on the Whois services, normally they would it would say, oh, what is my public IP address? You click that and then it will pinpoint exactly where you are. How does it know that? Well, it's through the service provider, right, that routes the information in. So your router has a public IP address, right? That's why they send you the router that you use at home or cable modem or whatever that you have for your service. So that has the public IP address. And then when we have all our system, our TV, our refrigerator, our smartphone, everything pointing to one public IP address, that's going to be overloading net. Any question? Static net information is here. Map 1-to-1. Overloading information is here. That's on page 5. So on the router, when you set this up, right? Let's say that we want to configure the Cisco router like this. It tells you here that when you setting up overloading NAT, you have to make sure that you create permission or you permit. So you would use the access list command and you would provide the permission by using permit, the IP address, and then the subnet mask. And when you configure the NAT, you would do IP NAT and then the inside source, and it's gonna look like this. Okay. So your interface would just be your connection point for that overload. It will be that port. Okay. So on the next part, it talks about port forwarding. This is a way that we can configure our system to forward packets to different areas of our network, like the DMZ or the internal network. DMZ is the place in between our public and our private. This is where our web server sits, right? The things that are public facing. And normally when we place the systems here, this is where you would have a lot of traffic that would visit. Like if I have a retailer store online, that will be my .com, so that way I can sell my products. But then the internal network, I would have like transactional databases and all of that, you know, like my internal employee systems and so on, right? So you can do this, you know, also on home use, you can port forward for other reasons, right? Like if you want to use a certain services for gaming or whatnot. So you need to specify the type of traffic that you are forwarding. That's really important. And also the addresses where that's coming from and where that's going to, which port. Okay. So that's the rule for port forward is we want to specify the service, the source, and the destination port. So for number 12, it asks you, which of the following options implies a configuration for network appliance to forward the packets to the system on the DMZ or the internal network? And the keyword there is to forward, so you have port forwarding. Okay, you're gonna see a similar question on quiz and exam. And we might also set up a lot of different type of proxy servers. Proxy can do a lot of things. It can act as a filtering system for us, like the traffic police, right? Like, you know how they put the checkpoints where they check every single car, right? Proxy can do that. Proxy can examine the type of traffic that's coming in and out. We can use proxy to increase bandwidth where we can divert certain type of traffic to certain area of our network. So for example, I have priority traffic. I can use proxy to be able to send that to a higher bandwidth area or the more priority utilized area for, you know, QoS, quality of assurance in the network environment. Or I can use proxy to be able to block, right, a certain type of request. So there are two types of proxy in our question here, the transparent proxy server and the non-transparent proxy server. And these are just network devices to act as a gateway to pass data from the client to the destination system. That's the transparent. It's able to be the middle systems that's going to pass the data from the source to the destination. The non-transparent proxy server, basically they are applications that point to the proxy servers. So it's just a pointer system. Now, attackers can also set up proxy to regulate your traffic or lure you to it, right? So reverse proxy, I'm sure you guys hear of things like that. In my classes, I like to use ZAP, which often or if you use Burp Suite, any kind of security tools, you often see that those type of tools is normally we would set up for proxy. So what you can do is you can take all of whatever your target traffic, bring it over to you, and this is how you're gonna be able to interrogate the packets. You can examine, and then you can tear down the packets and modify it, and so the application will do that for you, right? There are many ways that they can perform different type of attack, giving the resources. A lot of the time, proxy is the type of service that's often chosen for a network type of attack. So proxy is a very common tool that we see on both sides, right? Whenever that you use a tool for protection, normally that's the same tool that they use for breaking the protection, because you gotta combat with the same. So not the same exact tool, but the same type of concept. Any question? Okay, so for 14, we're going to identify the type of proxy servers given the scenarios that are listed. Question 14A. The server ensures that the user is authenticated to the network before being allowed to access the internet. This is for remote access a lot of the time, right? This is authentication authorization proxy. This is what you normally see being used for RRAS. So we have to authenticate to the network in order to access the internet. You guys seen that here, right? Whenever that you join a wireless network, guess what happens? You have to log in to RCCD, right? And because they're using the enterprise control, not the pre-shared key, so your authentication is your token to access the internet. Whenever you join wireless network, you see that. And we can set up a proxy just for that purpose. Authentication and authorization. Okay, let's take this down. Did anyone else need 13? We're good with 13, right? Okay, 14. Question B. The server allows the internet user to send requests to an internal web server, which is passed through a proxy to verify the request and forwards the request to the internal web server. So let's say that you have a web server inside, not on the DMZ. The user system is requesting the access for that web server. Like I would say, let's say abc.net, right? And that web server is on the inside. So this is a reverse proxy, because in order to get, normally the system requests the web access through the web server, but it has to go through a proxy in order to get to the web server. So it is a reverse proxy. This is a common type of proxy that you see for security. Very, very common. Someone can set up a reverse proxy. So whenever that you visit a whatever domain, right, you have to go through them. And this is also a way to bypass to a system. Question? And then we often see this in public school environment. We have server that blocks access to certain sites based on content, right? Like I would set up a proxy to block nudity, sexual content, implicit content, violence, anything like that, right? So because by regulation for children who are under 17, you gotta protect what information that they see on the system. So you have to, this is why school district on the computers there, you see that you can't access some of the common websites. So content filter proxy is a must.
That's basically like whitelisting and blacklisting certain sites where.
But what you do is you force them to go through that system. So let's say that the children visit youtube.com and YouTube is, so you have the way it's routed is it sends through that proxy and it checks. And then it sends out. So it is just a content filter. Now, you don't it's not necessarily just name, but you can just have content based. A lot of times we use text-based information, but you can also use now with AI, I think it is more intuitive on how we set this up. I think IT is a little bit more open with AI integration now. People are always afraid that AI is going to take over their job and things, but we're still controlling a lot of it. It's about, 70% accurate for most part. And then D, server contains rules that allow and disallow different internet protocols. Remember that protocols is tied to services, right? So if I block or I allow certain services, I do that through protocols. Not as content filter. Content is very specific to the things that they are using, right? Like gaming can be related to content, but we can also set up protocol rules to control and allow certain type of games, but it can bypass that. But if you do content filter and protocol rules combined, that will probably get you a little bit closer to what you want to filter. Now, if we blacklist, we continue to have to blacklist, right? Because things change all the time. And then with protocol service, system only use specific protocols like media, if we're looking at UDP, or if we're looking at specific like SMB for streaming or video conferencing and so on. Okay, so the things that you would use in real time or close to real time anyways, right? Like voice over IP. That's making calls using IP networks. And this is what you see with the phone systems in most business these days, right? The phone system, the actual phone on the desk has an IP address. It acts as like your regular IP systems. We manage them through, and voice over IP uses layer 4 switches. Okay. So we can, like in call center, you normally see switches being used. Video conferencing, that's very popular after COVID, right? We would see that desktop sharing. We see a lot of this for IT support and services as well. And then instant messaging if you're chatting. And so that's real time. And why is this important? You have to really identify the services that require real time because they are priority. Okay. So for a company like Twitch, right? All of this, most of this is priority. If you're looking at the element of Twitch, the user for Twitch, they're streaming and they're streaming live, right? And they're streaming live through a certain services like YouTube channel or other type of applications, or through Twitch itself, right? You also have communication where people type in messages and comments and things about that particular stream. So in that, you would have to consider that that's their money maker, really, because that the sponsorship behind it, the type of products that they're advertising or whatever that could be, that would be the quality of service is going to be required real time. So that becomes priority. So before we answer that, let's go to the next part here. So you can find more information about your proxy server. I did not include like caching or restricted sites. Make sure that you look at those. So you can use caching just for, if you have like web services that you want for it to quickly load, we normally use caching for that. And then restricted sites this is blacklisting certain type of sites. Not the same exactly as a content filter, this is content specific. Like if we're talking about nudity and sex, where restricted site is like specific sites like gamble.com. We don't want the kids to visit that, right? So that's separate. And then here it talks about unified communications. We just touch on those. Those are the priority real-time technology and the services. Many employers that interview network technicians and admin, they love asking about QoS. So make sure you understand what this is. And also for Network Plus, right? And this is important all around for network engineering. Quality of service, making sure that your experience using the network is good. That means that we have to have good performance. And what does this entail? Traffic shaping, right? COS, and we want to implement all of these things. So with that, we're going to answer the next questions. So what type of quality of service prioritize one type of network traffic by using QoS features to limit flow of that type of traffic while increasing flow of another type of traffic to ensure performance? Like what I said before, right? I might have a lot of systems that are trying to use different services in my network. For example, I might have people accessing my network to visit websites. But I might have, like in the case of Twitch, I might have people who are using the service to stream, right? I might have media servers, access, file downloads, etc. So what you can do is you can shape the traffic where you want to have your normal access, email, websites, traffic to be on one side of the network and or a certain part of the network. And the more priority type of traffic is going to be in the using the majority of your bandwidth or so that way your performance for your business is reasonable, right? So the quality of service is really strive to be able to produce good performance and availability of your network, because we want, if you're chatting, if you're using real-time applications, and if there's a lag, that means that your network is not performing as it should. Okay. So for the next question, it says, what type of switches is centrally configured across multiple virtualization system? This is a distributed switch.
For 16, would you use basically like a load balancer to?
Yeah.
do that?
Mm-hmm. Ideally, yes. Load balancer, and also a lot of it also comes with design too. You can throw a load balancer on there, but then if your backbone is slow, right? I worked for a place where, you know, they always try to add appliances on there, but the service that they were using going out to their service provider is very slow. So, and it bottleneck right there. So what happens is, no matter how fast your internal network is, right? Like if I'm communicating from this system to that system, it's very quick, right? Internally, our systems are quick, but whenever that we have like things that are coming in and out of for the internet, it's just slow because it bottleneck in that one section. So there had to be a way. So what they had to do is they had to either, you know, buy additional bandwidth from the service provider, and then think about how we would be able to set up proxy to be able to regulate some of the traffic going in, because you know some stuff is not as priority, and that's how you can shape it. Okay, so here it talks about how you can use diff serve, right? Setting up the rules for the traffic to assign it as priority. It's kind of like, you know, how when you go through traffic when you're driving, and then you know, like they tell you to stop, they hold a stop sign, and then they let that one side go because that's the main street, and it keeps going for a while, for 5 minutes, and you're waiting to do a right turn, and you're there for 5 minutes, right? Because that main street, they want more priority because there's more flow in that area, because there would be more car passing through. So efficiency, the way that Caltrans does that is If you have 100 cars passing through in 5 minutes versus 4 cars passing through in 5 minutes on this side, it's more efficient to open that flow, right? And the same thing that we need to think about when we do that for our network, okay? And then you also do DHCP. This is going to be for IP version 4 and version 6 header. This is how you're going to be able to look at your header fields to determine the type of traffic that you want to regulate. Okay, so when we do control, a lot of times in security or even IT, we talked about access control lists, your ACLs, right? And you see, where do you see this? The firewall, security appliance, intrusion detection system, all of those things. Basically, it's a file that contains a list of things that it checks against. Where it's coming from, where it's going to, how it's connecting for that, and the type of protocols it use or the service. Okay. And it's really simple. Those few things is going to allow or deny, right? These are some of the times the denied characteristics. And then distributed switching. So when I use an SDN software-defined network, basically I would be able to manage all the systems that are connecting with IP addresses, names, or changes on the system. So it is a short chapter. Okay, and lastly, for number 18, can you provide an example of software-defined network, your SDN? You can configure your network names and IP addresses for a virtually connected system. And what we can do is we can use script with this. Python is great for SDN type of environment for automations. We can use applications or appliances to be able to query the system or ping the system and check the status of the systems. So you can use SNMP with this to be able to supplement how you manage all your devices. I won't, if you're looking at enterprise admin, they're not gonna go around and check individually, out of the 1,000 systems that are connecting, you would have to use technology. Usually it's software, combined with hardware, and you will be able to manage. So normally you would see SNMP, simple network management protocol being used, integrated with software-defined network, right? So basically you configure your network names and IP addresses so that way you can set up virtually connected systems. Okay, I still have a little bit of time. I want to use like the next 15-20 minutes to kind of give you a little bit more subnet practice, because I know if I don't do it, we might not even get to the extra credit workbook. So, and then you should have enough sufficient time to do your switch and routers. And we are gonna have to, or your switches today, we're gonna have to share the appliance. So please work with whoever that you sit nearby or whoever you want to work with in small groups. And then I'll walk you through it. I don't have a switch to demo, but I will show you how you can get connected and then you can start from there. Okay. So let's go to if you go to the extra credit assignment, you can go through assignment for that. I think I had posted it in week 8. It's this one right here. The subnet workbook, and you can download the workbook. We'll go through a few exercises together. You just need to do 3. Okay, so when we look at the workbook, at the beginning, it goes over the classes, right? We established that. We talked about how the first octet, that's the ranges, and the usable classes are gonna be A, B, C. And this is at the beginning page, page 2. Okay? So make sure that you know the classes, and then it goes into the classes example. Normally you see these addresses being used. Okay? The default subnet mask. Okay, so let's go to and you can go down to each of the page, right? For example, like on page 5, you just need to take a look at the first octet, and then you just say which class that is. Like the 10, that's a class A, 150, that's a class B, 192, that's a class C, etc. Okay, so practice. Okay, I'm not gonna go over those because we've done that many times already. And then the next one, it's just looking at network, host ID. Circle the ones that you identify as network or host. Okay, so let's start with page 14. Problem 1. Let me look and making sure that you have the same thing.
It's the page 14.
Yeah, sometimes the pages are divided a little differently. Let me look. 16 for you guys? Let me check. This one. Problem 2, problem. So let's do one that we haven't done. So those are good examples. So refer to page 16 or 14 and onward. Right, or you guys already have all the solutions. So we don't really need, let me see. Let's do one together anyway.
At the very end, it gives you all the,
Yeah, the practice
the end, like, you go there.
still. Okay. So let's do one. Let's do problem 5. I think that's on page 20. Custom subnet mask. Let's do this one. Because you don't have it doesn't write it out for you. Right, this one. And then we'll take a break after that. Is it problem 5? Okay. So let's do this one together. Okay, so the problem tells us that we're building out this network and you need 6 subnets. 6 little networks, right? And this is going to tell us the exponent value that we're gonna need for the 2 to the n, right? And for each of the network, we're gonna need at least 30 computers or 30 systems that's gonna be connected. The address that they want to use is this address. So the first thing that you need to do is take a look at this IP and look at the first octet. 195, what class is this? That is a class C, right? Because this first octet, go to page 2 of the workbook. It gives you the IP address range, and 195 is in class C. So that's the first step. You need to identify the class IP address, or the class from the IP address. That's going to be class C. From that, you're going to say, what is the default subnet mask for class C? So that will be 255, 255, 255.0. Straightforward, right? Default subnet mask for the class. That's step 2. Now, the hard part comes is when we need to come up with the custom subnet mask. Before we write this down, we're going to ask ourselves, how do we get this custom subnet mask from the default subnet mask? We're going to come back to this first requirement. There are 6 subnets that we're going to build. So that requires you to have, right? We're going to have 2 to the power of n is equal to at least 6, right? So if I ask myself, 2 to the first power is 2, right? 2 times 0 is 1. 2 times 2 is 2. 2 to the second power is going to be 4. 2 to the third power is going to be 8. So this value 8 is going to be equals to 2 to the power of 3. Right? That's 2 to the exponent 3. You can write this with the superscript 2 to the exponent 3. Why 8? 8 is larger than 6, right? I can't have 2 to the second power because that's only 4 networks. I want to have at least 6 networks, so I have to have it 2 to the third power. That's going to give me 8. Okay? So that's what we established. And if you're using the student workbook, sorry, this is on page 20. Okay, so that's going to give me, yes.
What does that symbolize?
It symbolizes the exponent. So it's like 2 to the exponent of 3, like that. So the little caret really indicates. And you can get the superscript from the top right here, these buttons. This one, that's called the superscript. When you're using an exponent, right? So when what does this really mean? Some of you want to know, right? It's mean 2 times 2 times 2. So if I take 2, multiply it by 2, I have 4. 4 multiply it by 2, I have 8. It's not 2 times 3. It's 2 times 2 times 2 is equal to 8. Why 8? 8 is larger than 6. Why can I have it 2 to the second power? It's because it's 4. It's less than 6. I need more than at least 6, right? So I have to raise it to the third. So for the second requirement, it tells us that we need to have 30 usable hosts for each segment, right? We're gonna have 6 segments or 6 subnets. And for each of the subnet, we're gonna have to have at least 30 system or 30 system. Okay, so let's think about your borrow bits, right? This is our subnet mask. That's default. Network, network, network host. Okay, so the octet here and the octet here and the octet here represents your network ID. So when we're looking at the IP addresses, the first octet, network, 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 and the back part is going to be the host. Okay. So that means that we are going to have to lean into the host portion, and we're going to have to manipulate this value to be able to give us, right, the subnets that we need. Okay. So once you already have this value, we know that this represents the borrow bits, correct? Right? I need 8 networks to fulfill the 6 requirement. So this is going to represent the bits. So that means that it's going to be the 3 borrow bits here, right? I'm going to type it in binary, right? So to represent the 2. So it's going to be like this. It's going to be, see if I can, it's going to be 1, 1, 1, right? That's the 3 borrow bits and the rest are 0. 1, 2, 3, 4, 5, like that. Okay, sorry, it's kind of crunched together. So if you take that and you put it into your programmer calculator, okay, you put it on bin and you type in 1, 2, 3, that's our borrow bits, 1, 2, 3, 4, 5, 0, and you look at the decimal, it's 224. Why is it that? Because it's the 3 borrow bits here to meet the 8 subnet. And 8 is larger than 6. Okay. So I'm gonna borrow the 3 bits into the host, which was 0 by default. So that's how I get the 224 subnet mask. Everybody clear with that? Any question? So if I need 16, right, networks, then it's going to be 4 borrow bits and this value would change. So we established this. We got that borrow bits and the subnet mask that we wanted, the custom subnet mask. Now we got to determine, so here you can put down the 3 borrow bits because it's 2 to the 3rd power. So how did they come up with at least 30? Okay, so here's the math. So we established that there's 224 here, correct? Now you notice that I mentioned previously to you that there are 254 usable IP addresses starting with 1, right? Because when you reach 255, you're max. Okay, simple math. You take the 254, you subtract 224, you get 30. But you also have 32 left, subtract 2, you get 30. So there are about 30 usable IP addresses. Why? Because the difference between 254 and 224 is 30. That's quick math, okay? You don't have to do the exponent and subtract the additional two. I know that there's the last system, the last usable system, remember when we did the other way? The last usable system, it ends with 254. So if you take 254, subtract 224, you have 30 usable system in the segment. Okay. You don't have to do the extra subtract 2 like what they've done here. But the 6 is the usable network, right? And so how did I come up with this number, 30? I take, oops, keep typing in the wrong. I take 254, subtract 224, which is my subnet mask. I have 30 in difference. Why is it not 255? Because 255 is a broadcast value. It is not usable. There's only 254 possible usable per octet. So you have 30. And then you don't have to remember to subtract the beginning and the end, the host and the subnet mask value. So you have 30 usable IP addresses. Okay. So that's just one. All right. I will let you take a break. Let me stop recording.